let us look. Each time that you have a function, you should get an intuitive idea of its behavior. So we have a function which is of the type x squared over some constant constant k plus x squared. How does this function behave? For x0, it is at 0. For x very large, larger than the constant k, it is equal to 1. There will be saturation. For x equal k, we have k over 2k, it is at x equal k, the value is 1/2. And in between, for x small, well, what we'll have will be a function that starts as a parabol, as the parabol x squared. This is the function x squared for small x, which increases with a slope that varies continuously. The slope varies continuously, while for a linear function, the slope is constant. So it means that what we have is a S-like function. It's called a sigmoid function, or it's a S-like function. It is non-linear, as the slope varies all the time. This is non-linear even for small concentration, as for small concentration the curve behaves as a parabol. And so already for transcription factor that act as dimer, we have a switch-like activation of the gene. Then we could play the same game with transcription factors that act as tetramer or octamer, and by doing the same type of computation we did, we would find in the regulatory function, instead of the square, the order of the bound complex, either 4 for the tetramer, either 8 for the octamer, and which will translate in even more non-linear behavior of the regulatory function, even more switch-like behavior. Maybe this is why evolution led transcription factor to act as multimers rather than as monomer. This enables gene regulation to behave as a switch, gene off, gene on, sharply.